Boomerangs. These simple yet intriguing objects have captured the imagination of people across the globe for centuries, but what makes them so special? These curved wonders have fascinated people for ages. From ancient civilizations to modern-day enthusiasts, the boomerang has a unique place in human history. Imagine, thousands of years ago, people were already throwing these objects that come back. The earliest boomerangs were used by Aboriginal Australians, who perfected the art of crafting and throwing them. From Australia to ancient Egypt, boomerangs have a long and rich history. They weren't just toys. In fact, they were used for various purposes, including hunting and warfare. People used them for hunting, music, and even ceremonies. Aboriginal Australians, for instance, used boomerangs to hunt birds and small animals. They also played a role in traditional ceremonies and storytelling. Today we still marvel at boomerangs. How do they fly? The fascination with boomerangs continues as people of all ages enjoy throwing and catching them. But the real magic lies in their flight. Why do they come back? The answer to this question has intrigued scientists and hobbyists alike. The secret lies in the unique shape and the way they are thrown. The answers lie in the fascinating world of science. The aerodynamics of a boomerang are complex, involving lift, drag, and gyroscopic precession. These forces work together to create the boomerang's characteristic curved flight path. By understanding the forces of flight, we can unlock the secrets of the boomerang. Scientists and engineers study these principles to improve the design and performance of boomerangs, making them more efficient and easier to throw. Get ready for a journey into the heart of aerodynamics. Whether you're a seasoned thrower or a curious beginner, the world of boomerangs offers endless opportunities for exploration and discovery. So, grab a boomerang and join us as we delve into the science, history, and culture of these amazing objects. To understand boomerangs, we need to understand flight. Think of an airplane wing. Its curved shape is key. As air flows over the wing, it moves faster over the top than the bottom. This difference in speed creates a difference in pressure. The slower air below the wing creates higher pressure. The faster air above creates lower pressure. This pressure difference generates an upward force called lift. Lift is what makes airplanes fly. It's also crucial for understanding how boomerangs work. Boomerangs, like airplane wings, have a special shape. They are curved on one side and flatter on the other. This shape is called an airfoil. When you throw a boomerang, the airfoil interacts with the air. Just like the airplane wing, this interaction creates lift. But there's more to the story. When you throw a boomerang correctly, you also give it a spin. This spin is crucial for its unique flight path. The spinning motion creates a gyroscopic effect. This effect helps stabilize the boomerang and keeps it from tumbling through the air. The key to a boomerang's return lies in the way lift is generated. Remember how an airfoil creates lift? Well, in a boomerang, the lift is not equal across the entire wing. The spinning motion causes the top wing of the boomerang to move through the air faster than the bottom wing. This difference in speed creates a difference in lift. The top wing generates more lift than the bottom wing. This uneven lift creates a turning force or torque on the boomerang. This torque is what makes the boomerang curve in flight. At Section 5, the art of throwing, it's all connected. Throwing a boomerang is an art. It's a skill that has been honed over centuries, passed down through generations. The boomerang, a seemingly simple curved piece of wood, holds within it a world of physics and precision. When you hold a boomerang, you're not just holding a toy, you're holding a piece of history, a tool that has been used for hunting, sport, and even communication. It's not just about throwing it hard. The beauty of the boomerang lies in its elegance and the subtlety of its flight. A gentle throw with the right technique can send the boomerang soaring gracefully through the air, only to return to you as if it were a loyal pet. The key is in understanding the balance between force and finesse. The angle, spin, and even the wind conditions all play a role. Before you throw, you need to take a moment to analyze your surroundings. Feel the wind on your face, observe the direction it's blowing, and adjust your throw accordingly. The angle at which you hold the boomerang, the spin you impart, and the way you release it all contribute to its flight path. To make a boomerang return, you need to throw it almost vertically, with a slight tilt away from you. This might seem counterintuitive at first, but this technique ensures that the boomerang catches the wind just right, allowing it to curve back towards you. It's a delicate balance, one that requires practice and patience to master. The spin you impart is crucial. A boomerang without spin is like a bird without wings. The spin stabilizes the boomerang, giving it the lift and torque it needs to stay aloft and follow its curved path. The faster the spin, the more stable the flight. Hold the boomerang near one end and flick your wrist as you release it. This flick is what gives the boomerang its spin. It's a quick, sharp motion, almost like snapping your fingers. The position of your hand and the strength of your flick can make all the difference in the world. This creates a fast spin. Watching a boomerang spin in mid-air is a mesmerizing sight. The blur of its motion, the way it cuts through the air, is a testament to the perfect blend of art and science. Each spin, each flight, is a dance with the elements. The combination of spin, lift, and torque sends the boomerang on its curved path. It's a beautiful demonstration of aerodynamics in action. The boomerang's flight is a symphony of forces working together, creating a graceful arc that brings it back to its starting point. Mastering this technique takes practice and understanding of these aerodynamic forces. It's a journey of trial and error, of learning from each throw, and of gradually refining your technique. But once you get it right, the feeling of watching your boomerang return to you is unparalleled. It's a connection to the past, a celebration of skill, and a reminder that sometimes the simplest things can bring the greatest joy. Section 6, Coming Home, the physics of return. Now, the moment of truth, why does a boomerang come back? As the boomerang travels through the air, the unequal lift forces it to turn. This turning motion isn't just in one direction. The boomerang actually precesses. Precession is like the wobble of a spinning top. It's a slow circular movement of the boomerang's axis of rotation. This precession, combined with the forward motion, causes the boomerang to follow a curved path that brings it back towards the thrower. Section 7, A Boomerang for All Seasons, the challenges. Can we design a boomerang that always comes back no matter what? It's a tricky challenge. Remember, many factors affect a boomerang's flight wind, throw, even the boomerang's design. Designing a boomerang that overcomes all these variables is difficult. For example, a strong wind can easily push a boomerang off course. Even slight variations in a throw can significantly alter its trajectory. Creating a boomerang that compensates for all these external factors would require complex design and possibly even active control mechanisms. Section 8. Modern Boomerangs, Innovation and Design. Even though a perfect boomerang might be elusive, that hasn't stopped innovation. Modern boomerangs come in all shapes and sizes, each with unique flight characteristics. Some are designed for long distance, others for accuracy, and some even for multiple returns. Advances in materials and computer modeling have allowed designers to fine-tune boomerangs for specific purposes. Lightweight and durable materials like carbon fiber and plastics have revolutionized boomerang construction. These advancements have pushed the boundaries of what's possible with boomerang design. Section 9, The Future of Flight, Beyond the Boomerang. The science behind boomerangs goes beyond just these ancient tools. These curved aerodynamic marvels have fascinated humans for centuries, not just for their ability to return to the thrower, but for the complex physics they embody. When you throw a boomerang, you're engaging with principles of lift, drag, and angular momentum. These same principles are crucial in modern aviation and aerospace engineering. Understanding lift, spin, and gyroscopic effects helps us design better aircraft, drones, and even spacecraft. Engineers and scientists study the flight of boomerangs to gain insights into how to improve the stability and efficiency of various flying machines. The boomerang's unique flight path, which involves a combination of forward motion and rotational spin, offers valuable lessons in aerodynamics. The principles we learn from boomerangs have implications for all kinds of flying machines. From the smallest drones to the largest aircraft, the fundamental concepts of flight remain the same. By studying boomerangs, we can develop new technologies that make flying safer, more efficient, and more environmentally friendly. The boomerang serves as a bridge between ancient wisdom and modern innovation. So, the next time you see a boomerang soaring through the air, remember the intricate science at play. It's not just a toy or a simple tool, it's a testament to the ingenuity of human beings and our ability to harness the forces of nature. The boomerang's flight is a dance of physics, a delicate balance of forces that has been perfected over millennia. It's a testament to human ingenuity and our understanding of the natural world. The boomerang's design, which has remained relatively unchanged for thousands of years, continues to inspire and educate. Whether you're a scientist, an engineer, or just someone who enjoys throwing a boomerang in the park, there's always something new to learn from this ancient device. The quest to create the perfect boomerang might continue, but the journey itself is filled with discovery and wonder. Each throw is an experiment, each flight a lesson in aerodynamics. As we look to the future of flight, we can take inspiration from the humble boomerang, a simple yet profound example of human curiosity and creativity. The boomerang reminds us that sometimes, the answers to our most advanced